What if a single grain of sand could rewrite the entire history of life on Earth? Scientists have hunted for our planet's oldest fossils for decades. The discoveries they've made are stranger than fiction, locked inside ancient crystals, buried in remote deserts, and sparking one of the biggest debates in all of science. Finding evidence of life from billions of years ago is like trying to read a text message that survived a rock tumbler, a volcano, and 4 billion years of geological chaos. One lucky team found something incredible trapped inside a 4.1 billion-year-old crystal. They uncovered a potential chemical fingerprint of life itself, and it almost went unnoticed. This crystal is called zircon, acting as nature's ultimate time capsule. It survived continental collisions, volcanic eruptions, and enough heat to turn coal into diamonds. Deep within this ancient zircon, researchers discovered microscopic specks of pure carbon graphite. The carbon had a weird isotopic signature. It was light in a way that living things typically produce. Living organisms are picky eaters, preferring lighter carbon atoms because they are easier to process. When scientists found this light carbon locked inside a pristine, uncracked crystal, they thought they hit the jackpot. If this was truly biological, it would mean life existed just 400 million years after Earth formed. That is insanely fast, like life showing up to the party before the house was even finished.
Reality check. Think of it like receiving a suspicious text from an ex. It could mean something huge, or it could mean absolutely nothing. You need more evidence.
Other ways to make light carbon exist without life, meteorites, volcanic processes, and weird underground chemical reactions can all fake this exact signature. The 4.1 billion-year-old carbon remains tantalizing but unproven. Moving forward in time, we hit the next candidates. These fossils from 3.7 to 3.8 billion years ago initially had everyone excited. They came from the Nunavut Belt in Canada and the Isua Belt in Greenland. Canadian scientists found tiny tubes and filaments looking exactly like modern bacteria living near hydrothermal vents. The rocks even had the right chemical signatures. Case closed, right? Wrong. Other scientists pointed out a crucial flaw. These rocks had been through absolute hell. Multiple rounds of extreme heat, crushing pressure, and deformation turned the rocks into a geological meat grinder. Those fossil tubes could just be minerals that grew into tube shapes during all that chaos. Much like icicles forming in winter. The Greenland case was even more dramatic. Scientists found layered cone structures resembling stromatolites, the rocky monuments built by ancient microbial communities. Closer examination revealed a missing key feature, the upward curving layers that real stromatolites possess. Tectonic forces had simply squished and folded the rocks. It is like finding a suspicious footprint at a crime scene, only to realize your dog made it in the mud. Geology is exceptionally good at creating fake fossils. Do not lose hope just yet. Around 3.4 to 3.5 billion years ago, we finally get fossils that almost everyone agrees are real. They come from the Pilbara Craton in Western Australia. Scientists found beautifully preserved stromatolites in the Dresser and Strelley Pool formations. These are not just random rocks. They are layered structures built by ancient microbial communities working together like tiny construction crews. These stromatolites have all the right features. Proper layering, perfect shapes, domes, cones, wrinkly sheets. Formation in shallow water. The ultimate habitat for microbial life. Researchers also found actual microfossils, tiny spheres, lenses, and spindle shapes looking like individual cells. Chemical signatures prove these microbes were photosynthesizing without oxygen, processing sulfur, and even producing methane. This convergence of evidence is what scientists call a slam dunk. The morphology looks right, the chemistry looks right, and the geological context looks right. So what were these earliest confirmed life forms? Simple microscopic prokaryotes. They were basically bacteria without nuclei or fancy internal structures, living in communities called microbial mats. Here is something wild. These organisms were anaerobic. They did not use oxygen because there was basically no free oxygen in Earth's atmosphere or oceans back then. These microbes had to get energy from sunlight, iron, or sulfur. It is like discovering your great-great-great-grandparents were vegans who ate rocks and breathed underwater. Life finds a way, even when conditions seem completely impossible. You might wonder why scientists still argue about the older fossils if we have these accepted 3.4 billion-year-old ones. One massive challenge haunts every paleobiologist. Non-biological processes are incredibly good at copying biology. Nature is the ultimate plagiarist. Volcanic glass forms bubble shapes looking exactly like cells. Minerals grow into tube shapes mimicking bacteria. Tectonic forces fold rocks into patterns resembling stromatolites.
These are called pseudofossils, or abiotic mimics. Identifying a real fossil is like spotting a genuine diamond in a pile of cubic zirconia. Both can fool even the experts. That is why the standards for claiming you found the oldest fossil are insanely high. You cannot just point at a weird shape and declare it life. You need multiple lines of evidence, pristine preservation, and a geological history that has not been scrambled beyond recognition. Science is brutally self-correcting, which is frustrating in the moment, but absolutely essential for finding the truth.
The search for Earth's oldest fossils exists on a spectrum of confidence. 1. Speculative. The 4.1 billion-year-old carbon in a zircon. Fascinating, but unproven. 2. Contested. The 3.7 to 3.8 billion-year-old structures from Canada and Greenland. Hot candidates that got largely discredited after closer examination. 3. Confirmed. The 3.4 to 3.5 billion-year-old fossils from Australia. Almost everyone agrees these are legit. Even the confirmed 3.4 billion-year-old fossils show microbes that were already complex, diverse, and doing sophisticated metabolisms. They were not just barely alive. They were thriving ecosystems. This means life must have started even earlier, possibly back when Earth was still getting pummeled by asteroids and had a surface made of molten rock. Every year, our analytical tools get better. We can examine smaller samples, detect subtler chemical signatures, and distinguish biological patterns from abiotic mimics with more precision. Maybe tomorrow, someone will find actual microfossils from 4 billion years ago. Or maybe the 3.4 billion-year-old Pilbara fossils will remain our oldest confirmed evidence for decades. Either way, we do know that life on Earth is incredibly resilient, remarkably adaptable, and got started shockingly fast once conditions allowed it. We are talking about organisms that figured out how to survive on a planet that was basically a hellscape. These ancient microbes are our distant ancestors. Every cell in your body carries forward the legacy of those tiny pioneers who learned to extract energy from rocks, build communities, and persist through billions of years of planetary chaos. The next time someone tells you that life is fragile or that we are insignificant, remember our lineage. We come from a family that survived the worst the universe could throw at it, and we're still here, 4 billion years later, asking questions about where we came from. Over to you. What do you think? Will we eventually find confirmed fossils from 4 billion years ago, or is 3.4 billion the practical limit of what Earth's geological record can preserve? Drop your thoughts in the comments below. If this deep dive into Earth's ancient past blew your mind, smash that subscribe button. We have got more stories from the dawn of time coming your way, and you do not want to miss what we uncover next. Thanks for watching, and remember, you are made of stuff that has been fighting to exist since the very beginning of our planet. Pretty incredible when you think about it.